This is Sung, your online maths mentor, and welcome to episode 3 of Permutations and Combinations, the topic which basically looks at counting principles and relearning from scratch how to count, okay? In the last episode, we looked at a principle called the multiplication principle, and that particularly applies to working out the number of arrangements, or the other word is permutations, that that can be formed from a particular problem. Okay, so let's have a look and let's revisit what a permutation is. Permutation, right, is basically an ordered list, all right, where order matters. And another word that we can use for it in kind of everyday general vernacular is the word arrangement, right? So it's the number of arrangements that you can make, right? Where the mathematical word we use is permutation. And we looked at a specific example in the last episode, and I just want to revisit it, okay? Just so that we kind of can understand where we left off. So just quickly, the example that we used was the number of arrangements that you can make with the word maths, right? So if we were to rearrange all the letters, how many 4-letter words can we make from the letters in the word math, right? Where you cannot repeat the letters. And remember that we worked out that for the first position here, right, you've got 4 letters in the word math, which means that you can put 4 letters in the first position. For the second position, because we've already chosen and nailed down the letter in the first letter in the first position, you'll only have 3 letters left. Yes? So it's going to be 1 less than 4 that you can select from or choose from for the second position. So you've got 4 possible positions in the first position, or so 4 possible choices in the first position, 3 in the second. There'll be 1 less for the third position, so you end up with 2. And whatever's left over, you'll only have 1 choice left, fits in the last position. Does that make sense? And so what you end up with using the multiplication principle is the multiple or the product of all the numbers or the whole numbers that are less than 4, starting with 4. So 4 times 3 times 2 times 1. 4 times 3 times 2 times 1 can be written another way, right? And that is 4 with a little exclamation mark, right? And that 4 with a little exclamation mark is a shorthand way, all right, of basically expressing what's going on here. 4 times 3 times 2 times 1, where you multiply each number 1 less than the starting number, okay? Until you multiplying all the numbers that are less than that starting number, all right? So that is what we call factorial notation, right? Factorial notation, right? So in other words, 4 factorial is 4 times 3 times 2 times 1, and that will give us, all right, so if you want to know why we need factorial notation, basically it gives us the number of arrangements without repetition, where you start off with n choices for the first position, right? So where n is the number of choices for the first position, and each position after it has 1 less choice to make. All right, so that's why factorial notation is important. So just to repeat again, to express the product of all the whole numbers less than or equal to n, we actually write n with a little exclamation mark, which is basically n factorial. Got it? So now I basically want to do a couple of quick exercises with you, just so that we can really get a handle on what factorial notation is. So let's start with 6 factorial. What is 6 factorial, right? Basically, 6 factorial written in longhand would be 6 times 5 times 4 times 3 times 2 times 1, yeah? Punch that into the calculator and that will give you a set number, all right? And that would be the answer for 6 factorial. Okay, 10 factorial, all right, will be, let me come over this side, 10 factorial will be 10 times 9 times 8 times 7 times, can you also see that it's going to be 10 times 9 times 8 times 7 times, and here's where I'm going to be sneaky, 6 factorial, right? We can actually write it like this. So 6 factorial, right, is 6 times 5 times 4 times 3 times 2 times 1, right? So we can actually write it as 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Or what we can do, and sometimes this might be helpful to see, is that 10 factorial is equal to 10 times 9 times 8 times 7 times 6 factorial, okay? Now, why am I doing this? More than anything, to show you that we can be creative with it, right? More often than not, it's easier, or probably more standard, to write 10 times 9 times all the numbers back down to 1. But I've done this specifically because I want to show you how that'll apply here. All right, where you see something like this, 9 factorial over 5 factorial, right? What I want you to see is, all right, that 9 factorial is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, and it's really tedious just writing all the numbers like that, right? And then 5 factorial is 5 times 4 times 3 times 2 times 1. Got it? So this is 9 factorial in longhand. This is 5 factorial in longhand, right? What I want you to notice is that 9 factorial over 5 factorial actually simplifies, right? Because if you remember fractions, right, and simplifying fractions, you'll see that 5 cancels with this 5, this 4 cancels with this 4, this 3 cancels with this 3, 2 with 2, and 1 with 1. Do you see how that works? How they all cancel out? 9 factorial over 5 factorial ends up being the product of 9 times 8 times 7 times 6. Got it? So 9 factorial ends up being the product of all the numbers from 9 to the number just above 5. Got it? So, I'll just do one more example and I'll end off here because this will set us up nicely for the very next episode, right? And that is, if we wanted to work out what, say, let's try this, 13 times 12 times 11 times 10 times 9 is, right? How would we write that in factorial notation, right? In factorial notation, it's going to be something very similar to what we've got here. What I want you to notice is that 13 all the way to 9, right? 13 times 12 times 11 times 10 times 9 will be 13 factorial all the way down to the number just before 9, which is 8 factorial, okay? Does that make sense? Yep. Basically it does, because what you've got is you've got 13 times 12 times 11 times 10 times 9 times whatever's left over, which is 8 factorial, over 8 factorial. The 8 factorials cancel and you're left with 13, the product from the numbers, the whole numbers from 13 all the way to 9. Does that make sense? Cool. So what I want you to do is just be familiar with what's really going on here, because that will set us up nicely for the next portion or the next episode of this particular unit of work. Okay? I know things might have gotten fairly simple up until about here, but see if you can really go away and understand what's going on. And I will see you on the next episode. Thank you very much for watching.